right, here we are. Hi, John. Hi, Joel. How are you?
Good, man.
Yeah, thank you.
Great to see you. Hello, everyone. My name is Jules Hilliard. I'm the CEO of Secure Block Tech. Welcome to the first of our series of weekly podcasts. Hope you enjoy this journey with our weekly guest panels as we discuss enterprise blockchain. As you know, there's a ton of information out there on cryptocurrency, Bitcoin, and the like. However, we want to discuss blockchain as an application architecture, network infrastructure, distributed ledger technology, cybersecurity, AI, and the way blockchain technology can change the IT landscape as we know it. A much larger footprint than just digital currency. But before we do, I'm going to do a quick plug. Hope you don't mind. I founded SBT in 2017 and brought in a great team of the usual suspects from my Rolodex. Veteran enterprise technologists that have been focused on the adoption and utilization of blockchain technology by the enterprise. We have built the first of its kind enterprise-grade BOC, or Blockchain Operations Center. You already know the importance of a NOC and a SOC for today's dynamic networks. The need for a BOC is here, and we're here to provide the solution to the market and stimulate mass adoption. Our platform provides a single pane of glass, if you will, to develop, deploy, and manage all of your blockchains and dApps from one centralized management console. Monitoring, analytics, security, and optimization are at the core of our technology stack. Today, I have two of my colleagues and good friends, Joel Semengen, our CISO, and John Hooks, our CAIO. John, let's jump in with you. You're Chief Artificial Intelligence Officer. John, you joined our team in its infancy stages, published author on blockchain, has been heading up our efforts on fleshing out how AI can be utilized to enhance the functionality of our platform and the industry as a whole. Tell us a little bit about your thoughts on enterprise blockchain to start, and why you feel that current AI systems are not trustworthy.
Sure. Well, thank you for the introduction. And let me tell you that, as you mentioned, I'm a published author. The latest book I did with my colleagues is a textbook called Blockchain Economics. And I think the title speaks for itself. This is not just about a technology that's being used or will be used extensively in enterprise IT, and we all believe that, but this is going to form the basis for an entire economy built and run and completely viable as an alternative to some of the economic models we have today. And if you get a chance to get a hold of that book, you'll see there are various pieces of that puzzle. But one of the pieces that I focused on, and that we're focusing on here in our work and research around this, is the fact that blockchain and DLT, separate apart from cryptography, which is a little bit different body of science, is really about provenance and chain of custody. And provenance and chain of custody specifically about data, right? So we all know that data of any form can be created and changed easily. And what we're seeing in the AI space now is that, remember the old saying, GIGO, right? Garbage in, garbage out. If you take in or ingest information, data, whether it's pictures, graphics, data, and you put it into a machine learning model, then whatever you get out of the back end, it's going to calculate the probabilities based on the training model of what that particular situation is, whether it's a stop sign you're recognizing, because you're driving your Tesla and you want it to drive itself, or whether you're looking for threat actors in an airport. If they are able to take the data that's coming into the camera or through the Tesla brain and modify it in some way, then the outcome of automation, which is what we're driving for, is going to be totally different and unexpected than what you thought when you originally built the model. So what I'm seeing today is that threat actors are using what is called adversarial AI to go in and modify these AI-driven systems such that it provides not only an economic gain for them, but could potentially, bring down an entire power grid if that particular piece of power grid was automated in some way, and we know it is being automated through what we call the smart grid.
Absolutely. Good stuff. Good stuff. Thank you for that. Let's jump over with Joel. Joel's our Chief Information Security Officer. Joel, you and I go way back. I mean, all the way 20 plus years here in information technology, all the way back to my load balancing days, which seems like forever ago, where we were inventing load balancing as we went. Joel was heading up the security and implementation team at a large fintech company that was inventing internet banking at the time. And we did a lot of great work in the sandbox and getting our functionality working and deployed into their fast-growing global network. Joel, thanks for being here with us.
Thank you. Glad to be here.
Absolutely. As a CISO and information security officer, what can you tell us about blockchain security and how important it is given the increasing data integrity threats that come across various industries?
Excellent. Yeah, thank you, Jules, and I'm glad to be here. Well, before I answer the question, I want to set the stage first and make sure we're on the same page on what blockchain is about, right? So blockchain is basically, simply put, it's an open distributed ledger, which records electronic transactions in a verifiable and permanent way. And it's basically typically managed by a peer-to-peer network that follows protocol for the internode communication and it validates the new blocks within the chain, and hence the term blockchain. So to answer your question, Jules, it's important that, as we all know, it's all about protecting the integrity of the data. That's basically our crown jewels for most of us, intellectual property and such. So with blockchain fundamentals and its inherent network security, it basically brings in that the records are basically immutable. Once the records are validated and recorded on the chain, they are basically unalterable. And because of the embedded metadata as are adhered into the transaction, it cannot also be separated or lost or altered. And then additionally, the user's integrity is verified using asymmetric cryptography, the digital signatures and transactions, which are also added into the blockchain. And there's also full transparency of transactions which are visible and auditable to all the trusted users in the blockchain network. So having said all of this, that basically puts a big kind of shell or additional security control into your business transaction, having blockchain as part of your security solutions.
Fantastic. Appreciate it. Great information. Thank you for a great start.
Thank you.
John, back to you. What are some of the common end goals of attackers when they attack machine learning systems?
Well, we talked earlier about adversarial AI. So there's really two ways that attackers look to change or modify something within the AI machine learning system, right, within a company or organization. The first is like a white box attack. So that basically says they're going to take the data, and as Joel mentioned earlier, it could be extremely important data like property records, financial data. It could be, visual data like, taking photographs of individuals, within your organization. And they go in and they're able to modify through techniques that are well known that data. For example, they can take a picture of a cat, and by modifying a few of the pixels, not many, get access to the file that that particular picture of a cat is in, they can introduce noise such that those pixels change that picture as an AI or a machine learning model would see it, and as it's training data to recognize a cat, the cat will show up as a dog, for example, or whatever you want to. With certain combinations of pixelation, you can change the cat to look like an airplane. And again, to the human eye, it still looks like a cat. But to a machine learning algorithm that's training this data coming in from one of the more standard programs, it's going to modify it. So they go that approach, which is to modify the data. And again, back to Joel's point, blockchain pretty much solves that problem. Puts an additional pillar of security into the CIO or CISO's wheelhouse that says, if I blockchain data in an enterprise, chances are very slim that anyone who tries to modify that data is going to be able to do so, because as we all know, it's going to be, quote, immutable, and it's going to raise a red flag, hopefully through a monitoring system like we're talking about, a blockchain operations console or center, that says, hey, someone's trying to modify it. So not only will you know if it's being modified, but if it has been modified at all, what to do and take that piece off the chain, or make it inaccessible by systems that need to use that information, right? The second approach is called the black box approach, and that's where they go in and they're able to find or compromise the algorithms that are part of the machine learning model that's being created. And these generally are done by insider threats, which is a huge problem, right? So someone who understands the models that, for example, create credit scores can go in and modify the weightings of certain aspects of the credit score so that it comes up in their favor or someone else's favor, right? So they get pushed through all their friends who otherwise would probably get a very low credit score, and now by modifying that particular aspect of the machine learning algorithm, they look like they're superstars, right? Give them all the money they want. So those are the two major ways that can be done. And it's pretty common nowadays for people to understand that it's pretty easy to attack a machine learning model or system based on those two ways I just described. In fact, Gartner Group has done a survey recently that said, do most people who rely on machine learning and AI systems trust them? And there's a huge gap now between the trust of AI systems and their use. And most people will say, I may not accept that. Because again, these AI and ML systems are based on probabilities and statistics. So again, it's not a fail-safe method. And the attackers that know them well know that and modify them. So again, the white knight coming on the stage in the very near future is the enterprise blockchain adoption of this. But again, like any other system that has network traffic, you need to monitor it. And you need to make sure that you have alerts built in that say someone's monkeying with this data, and even though it may be, quote, immutable, you need to flag it so it doesn't get further down the chain in some way and used surreptitiously.
Definitely a lot of great information, and I also feel like you did a fantastic job of helping people understand what we've thought from the beginning and why we've been developing the solution that we are developing. Now, Joel, what are some of the methods that can be utilized to defend and protect this kind of attack?
Yeah, that's actually a great question, which is very timely for what we're doing at SBT. It's very important, just like anything else, throughout the advancement of technology, year after year after several things as being adopted or brought up by various technologists, and again on the flip side by the bad actors. So what's critically important is to have a good and active monitoring system. We all know that most organizations, strong organizations, have a NOC and even has advanced to having a SOC, Security Operations Center. So in this case, having a BOC, which is a Blockchain Operations Center, which would be in perspective like the third leg in the stool, would really solidify and help into the identification and prevention and the defense with regards to the attacks that John had articulated. And what's critical about that is it brings to light from an organization on what is actively happening within their blockchain systems, and they can also identify any anomalous activities. But even before talking about the anomalous activities, it's critical for the organization to set a good baseline and tune their monitoring systems and portals to identify what's considered a good traffic versus bad traffic. So the organization will be the best to know and identify and tune their bot systems to be able to set alerts and flag any or alert any anomalous activities, transactions, or behavior that's outside the norm. And again, given a lot of the AI activities and automated systems, this may be a very taxing process, but it's again, the advice is to set up a good baseline, and it will be an ongoing tuning process, because as the systems and the organizations try to move forward with their business, make some adjustments, provide some additional features, products, and services, it will be an active effort to adjust and set the baseline in accordance with their current business practices. And obviously, all of these alerting mechanisms will then help protect and defend against potential attack, and then which leads to further, and what's important is timely investigation. It's just like anything else. I mean, unless somebody identifies and reports that there's an active breach or potential breach, the bad activity can potentially get unnoticed and start getting deeper into your systems, sometimes maybe late into the game by the time your alerting systems get tripped. So hopefully, again, the key is having it in the very front and getting a good set of baseline for alerting those bad behaviors at the beginning. And then you may want to have an ability to take a step back and review your DevSecOps methodology practices, just to see if it's still sound and it's meeting, again, some of the adjustments that your business may have done to ensure that those practices are still in alignment. And lastly, as I mentioned at the beginning, the timely investigation, which kind of leads into a very robust incident response plan and procedures, is key. Make sure that you perform ad hoc practices to be able to practice potential or simulate bad traffic and anomalous behaviors, and see in each one like a tabletop exercise on how your teams and respective incident response support teams will behave as rapidly or quickly within your designated plan and procedures as approved by your organization.
Fantastic. Thank you, Joel. I know, as we all heard, with blockchain, everybody coming out with all this great functionality, transparency, immutability, and the built-in security, I know we all looked at each other and said, trust me, isn't really going to cut it for the enterprise. You know, and I'm happy to show you guys, actually, as we're deploying on AWS. As you know, the team is telling me they're rolling out Alerts 2.0. on this deployment. So I can't wait to show you that next week, and for those clients that are also adopting blockchain as well. Well, John, Joel, great stuff for our maiden podcast. I want to thank you both for joining me on our new weekly podcast as we roll this out, hopefully educating and attracting more technologists and advocates for blockchain technology. Thank you for joining me.
Thank you, Jules.
Thank you.
Absolutely. And I hope that you, the audience, found this talk interesting and informative. Please join us weekly as we have many exciting guest speakers scheduled. And as we continue to explore blockchain technology and the many use cases that it has above and beyond digital assets, you can learn more and or contact us at secureblocktech.com. Have a great week, and please reach out with any and all feedback, questions, or desire to join the blockchain revolution. Have a great weekend, guys.